So in this video, we'll be covering composite and inverse functions. This is part of the IB, AA, SL, and HL course, part of the unit functions, and this is 2.5. So let's start with composite functions. Let's say we have a function f of x is equal to x squared, and another one, g of x is equal to x minus 1. So we know the input of function f is x and the output is x squared, and that the input of function g is x as well, and the output is x minus 1. Now let's say we want to combine both of these. Let's say we want f of g of x. What would that be? So we would simply replace every part of function f that has x in it with the function g. So it would then become x minus 1 squared, because x minus 1 is what we have of g, and then if we plug that into f, everywhere we have x is just x squared, so that it will become x minus 1 whole squared. Basically what this is doing is it's turning the output of one function into the input for another function. So basically the output of function g is now becoming the input for function f when we do f of g of x. And be careful when we read this. If we see something like this, it's f of g of x, f of g of x. Or if it's f dot g, it's still the same thing. You can just say f following g. This just means that we need to be careful of what order we're applying the two functions in. It needs to be, let's say we have f of g of x, okay? We need it to go in the order of x as the input of g of x, which is the input of f of g of x. It needs to go in that order. And basically how I remember it is that, let's say we have f of g of x, right? We always take what's inside first and plug it into whatever is outside. So if it's g of x, I take whatever g of x is, in this case it's x minus 1, and plug that into whatever f is. That's the way I work. I see whatever is inside goes first. Or you can just remember the order. It's pretty simple. Now, that's pretty much what composite functions are. It's just combining two functions. Let's look at an IB style exam question on composite functions. Okay, before we look at an exam style question, I have this diagram here that might help in understanding the order of the composite functions. So basically, this is the function g, the first box, and we're putting in x, and the output would be g of x, and then this is the function f, the second box, and we're putting in g of x, which is the output of the first one, and then we get f of g of x. It's just something that might help you guys. So now let's look at an IB style question. Let's say we have this question. It's actually an AAHL question, but it's extremely easy, so I think AASL, it's good practice for you guys anyway. Plus it's pretty simple. It's just a basic level. But anyway, let's solve it. So part A, we're already given the two functions. We know that f of x is x squared plus 2, and that g of x is x minus 3. So to find f of 3, we just plug in 3 wherever x is, and that would become 3 squared plus 2, which is 11. Simple enough. Part B, we have to find g of f of 3. Now we already know what f of 3 is. It's 11, right? Again, we have to work inside to out. So that basically becomes g of 11. And then we substitute 11 for wherever x is in the function g. So g of 11 would equal 11 minus 3, which is 8. And finally, part C is inverse, so that the notation is g to the negative 1 of x. We'll get to this now. Okay, now let's have a look at inverse functions. Now, some of you may remember that in subtopic 2.2, we already learned the meaning of inverse functions. So if you don't know what they are, you can go watch that video first. We explained basically what inverse functions does. It's basically switches the outputs, the inputs, the domains and range, and the inputs and outputs. So let's say we have, very quickly, we have all the inputs here and all the outputs here. And so f of x would, generally go from input to output, okay? But what the inverse does, so what f negative 1 of x, so it's not actually said f negative 1 of x, it's inverse of x. It actually goes backwards, so it goes from output to input. And so one important thing we need to remember is that the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. Now, I hope this makes sense, because if you're switching the inputs and the outputs, obviously the domain and range will change, but the convenient thing is they just switch around. So if you know the domain for the original and the range for the inverse, you basically have the domain and range for both of them. I hope that makes sense. Now let's look at an example. Let's say we want to find the inverse. Example. Let's say we want to find the inverse of f of x is equal to 1 plus 5x over 3x minus 2. Now, to solve any question related with the inverse of a function, there are 4 clear steps that we need to follow, and these steps stay the same throughout. I list them on the side here. Step number 1, rewrite the function as y equals f of x. So let's do that side by side. Step 1, we'll do y equals 1 plus 5x over 3x minus 2. Okay? Step number 2, replace all the x's with y's and vice versa. This is an important step because this basically is the main step in the inverse. So all the y's become x and all the x's become y's. So it would be x is equal to 1 plus 5y over 3y minus 2. Notice how the x and y have swapped. And actually, they're not even 4 steps, they're just 3. And now what we need to do is solve for y. So once we've swapped them, now we solve for y. Now let's say we just bring this to the other side. we'll bring all the common ones to one side. So we'll do 3yx minus 5y is equal to 1 plus 2x. We'll take y common, 3x minus 5 is equal to 1 plus 2x. So we get y is equal to 1 plus 2x over 3x minus 5. And then what we can do is just change this back to f inverse of x is equal to 1 plus 2x over 3x minus 5. And these are the 4 steps to finding the inverse. It's pretty simple, and they all follow the same pattern. Now let's look at the example that we did for composite functions and solve part C. Okay, so this was the question we had before. Now, since we know how to do inverse functions, we can do part C, and we can find the inverse of g of x. So let's follow our steps. I'll do it in green for us to see easily. Okay, we know that g of x is x minus 3. First, we write it as y equals x minus 3. Just turn the g of x into y. Whatever it is on the left-hand side, if it's the function, like if it's f of x, g of x, anything, just turn it into y equals the following function. Now let's swap our x and y's. Make sure that you do this because otherwise you're just solving nothing. So x equals y minus 3, and now let's just solve for y. So x plus 3 is equal to y. So g inverse of x is equal to x plus 3. And that's our answer. It's as simple as that. So composite and inverse functions both are pretty simple. They all just kind of follow the same. Both of them have kind of a strict procedure. And once again, if you are confused with the idea of an inverse function, go watch video 2.2, which explains what inverse functions are. And we'll obviously see them more often from now on. And I'll explain them further. But that's it for this video. Yeah, bye.